The goal of this talk is going to be to focus on unit testing mostly, but we're going to cover lots of concepts that can apply to any kind of testing. So beforehand, let me introduce myself. My name is Xavier Gouchet. I've been writing Android apps for like 9 years now. I'm lead Android engineer at Workwell, and you can have, this is my Twitter handle and GitHub and Stack Overflow and everything. Just to talk about Workwell for a couple of minutes, basically the idea is that we want to provide an application that will improve the users, the employees' well-being at work. And when I joined Workwell about a year ago, the tests were not enough and not good enough. So this is the opportunity to talk about how to have a good unit test and good testing on your application. But first of all, let's go back to the basics and say, what's the goal of unit tests? The main goal of unit tests, everyone agrees, is to verify that the code works. But it's not the only thing that you need to worry about. One important thing is that you want to make the contract explicit. When you write unit tests, you are writing black on white or white on black, depending on your theme, what your feature should do exactly. Also, it can guide the development if you're using TDD, and I'm going to come back to TDD a bit later. It can prevent regressions, because when you have tests that cover your code, basically when someone introduces a bug, the tests are going to find it. And the regression can be caused by any other developers or ourselves in the future, or changes in third parties dependencies. And because you have regression, you prevent regression. You can also ensure the retrocompatibility with old version, and it eases maintenance. And of course, the main point is that it increases your confidence in the code that you're writing. Because the goal of your code is to be executed. And there are only two ways to do that. Either it's executed on your user's devices, or it's going to be executed in the test. And testing is the best way and the fastest way to make sure that the code is executed fully. So there are different kinds of testing, and to make sure that we all understand it, we're going to use a parallel with music. So basically, unit testing is like an audition. You have a single performer, and you're going to make sure that they know how to use their instruments, right? And then you're going to have integration testing. Integration testing, you're going to have like a couple of performers and make sure that even though each one is able to perform on their own, they also perform well in harmony together. And then you have functional testing. Functional testing is basically like your dress rehearsal. So you are testing everything with all the technical requirements. So it's going to be including real network, it's going to be including real screen, real devices, and everything real as the user would experience it. And then you have, of course, test-driven development. And test-driven development is basically making sure that you write before what you expect your code to do, instead of testing afterwards. Lately, you have the concept of code coverage. I'm going to have a few slides on that later. But basically, the idea of code coverage is a measure of how much of your code is actually tested. So these are the basic concepts. So then we can ask the question, why not write unit tests? It's 2018, almost 2019, and there are lots of startups that they go to conferences and they learn, and still they don't do any kind of testing in their development, in their workflow. And whenever there is that, I always ask the question, why do you not write unit tests? And we're going to see a few examples of the reasons, but the short thing is there is no good reason not to write tests. The first reason is that people think they don't need tests. There is this motto that says testing is doubting. So if you test, it's because you're not sure about your code. But actually, if you don't test, how can you be sure that your code does exactly what you want it to do? Some people, and I've been in that place, say that they don't have time because they must ship the app already, like today, and they don't have time to write tests, or it just takes too long to write the test. For the fourth point, there's nothing really we can do except allocate some time during the sprint planning to say, okay, I'm going to introduce less feature, but I'm going to take some time to test them. The other point is that the more tests you write, the easier it's to write them, and it's the fastest is to write them. The last point is I don't know how to write tests. And well, if you don't know what to test, you're in the right room. And if you don't know the tools, I'm not going to go in details over that, but there are lots and lots of tutorials online that you can find for your platform and for your languages that will tell you how to write tests. But the main question is, I don't know what to test. So we're going to see a bit about that. So I said I'm focusing a bit on unit testing because it's the first step into testing. The unit in unit testing is, first of all, let's see what's not to test. What not to test is you don't have to test third-party libraries. So you don't have to test like RxJava, you don't have to test retrofit or any library that you're using because it's not your job. You don't have to test the framework, of course. You don't have to test Android or Linux or iOS or whatever. You don't have to test the network, because the network, by definition, is going to change. Because one day you're going to have a very good network, the next day you're going to have a flaky network, or you're going to have some server errors that are going to make your test fail, even though your app didn't change. So you don't test the network, you don't test the APIs. You don't test the language too, because you can just assume that Java or Kotlin or Swift or whatever, or that your build toolchain is going to work correctly. And if it doesn't work, if you have problems, it's not your job to fix them, and it's not your job to detect them. And finally, you don't have to test trivial code. Some people think they need to have 100% coverage, but we're going to say that it doesn't mean anything. So testing getters and setters is pretty useless nowadays, especially if you're using data classes in Kotlin, because everything is generated for you. So next, what do you test? The most important thing is to test your decision logic. That is every if, switch, when, every for loop. You need to test that. Whenever you have some transformation of some point, like you have some input that you convert into some output or into anything else, like deserializations, parsing, etc., you need to do that. Only if you do it manually. Like if you're using any automatic parsing library, any automatic serialization library, you don't have to do that. You don't have to test it. You need to test also the callbacks events. Like whenever you have a feature that should trigger like an on-click or on-touch or whatever event, you need to test that the event is actually sent to the listener. And of course, you need to test all the critical code. And by critical code, I mean either the code that's going to change a lot, or the code that's a lot of people are going to change. Because this is where the bug can come very, very fast. So what's the unit? The unit in unit test. A unit, it's the smallest piece of code which you can test without having it coupled with anything else. So in lots of tutorials, they say a unit is a class. No, it's not necessarily a class. It can be a class, it can be a method, it can be a group of classes. Basically, a unit is the smallest amount of thing that you can test without including any other code in your code base. So how do you write, once you know what you want to test, how do you write it? The first thing is to isolate the tests, the unit that you want to test. So you can use dependency injection, you can use other ways, but basically you need to make sure that you cut everything else from the part you want to test. Because you don't want to test something and have some other code that you don't control in your test introduce bugs in it. Then you need, of course, to extract any irrelevant codes to delegates, listeners, data sources, anything else, you move that away. Then you need to write down the unit's purpose. What's the purpose of the thing you're going to test? What it's meant to do. And then you need to write down every known and unknown use case. And talking about that, you need to consider everything. Like you have the good use case. It's the the standard use of your feature. Like when you have a proper input, you have a standard email address, you have a number that's kind of normal, and all the system that you're testing is in a proper state. Then you have the bad cases. It's like any unusual input, but that's still valid. Like that email address is still a valid email address according to the email specification. But a lot of system, if you type that in, are going to say, this is not an email address. Well, still, it's valid. It's when you have numbers, it's considering for very high numbers, or if you have floating point numbers, it's very, very, very tiny numbers. And the ugly, of course, is any unexpected input, like null, infinity, not a number, anything like that. Any invalid state, you need to handle it, because usually when you have, all the bugs, they always happen when, well, we shouldn't ever be in this case. Well, sometimes we are. So when you have written down all the test cases that you want to do, how do you actually write the test? Well, each test should have the same kind of structure. You can see it named in different ways. You have arrange, act, assert, or you have given, when, then, or you have set up, exercise, verify, and tear down. But basically, the main points are: first, you prepare your unit and the test that you're going to use with it. That's the first step. You prepare everything. Then you actually call the feature you want to test. So it can be a single method. It could be a couple of methods that you want to test sequentially. It could be more. And then you verify the outputs or the states of the callbacks. So you need always to have something that verifies that you actually call the method, for all of the listeners, that the results, the output is correct, and that the state of your objects are correct. So then there are test conventions. This is something most companies have coding conventions, saying, okay, when you name a class, you should name it like that. When you write an object, you should use this. When you have a database, we should use this template. And when you have tests, you need to have the same kind of conventions. Because if everyone writes tests the same way, everyone can read them more easily and maintain the code better. So I'm not going to say which convention you should use, of course. We can talk about it afterwards, and I can give pointers, but you need to decide these things and have them written down, so that, first of all, everyone writes the same way, but also it's a guide for new employees to know how do we write tests in here. So, golden rule of tests and unit tests is that first a test needs to be fast to execute. And that's very important, because during development, in theory, you should execute your test often. If your test takes more than 5 seconds to execute, and I mean 5 seconds from the moment you hit the test button or the keyboard shortcut, you're going to lose your mindset. You're going to drift into thinking about something else, and you're going to lose some time, because then when the test result comes, you're going to have to come back to, oh, what was I doing again? So it needs to be fast. It needs to be reproducible. If you run the same test twice and you don't have the same results, then there is some problem somewhere. And it needs, of course, to be reliable. Reliable, it means that you need to be sure that your test actually is a safeguard against your code. So we're going to see some example on how to do that. And the main way some of you might have heard of is TDD, which is test-driven development. And TDD is basically this idea that you should write the proof of your program at the same time as you write your program. It should grow at the same speed at the same time. And this dates from 1972, so it's a very, very old idea. So this is the TDD loop. It's very, very basic. You have 5 steps, and you just do first step, second step, third step, and just repeat all the time. This is a TDD. So we're going to see each step in detail. First step is you write the simplest test ever that will fail. So here, the test-driven development means that the test is written first. Why we do that? It's to avoid overcomplicating things. Like sometimes you start to write a feature and you say, oh, I'm going to use this design pattern, I'm going to use these classes, and in the end you don't need all this huge amount of code to do the simplest thing. So when you write the test first, you're going to say, okay, how am I going to use my feature? I don't want to know how it's going to be implemented, but how I'm going to use it from the outside. And that way you're going to write the simplest and most efficient, in theory, implementation. Then you verify that your test fail. Verifying that the test fail makes sure that when it actually succeeds, you know that it can fail, right? Because basically, if all your tests are green from the moment you write them, and you never see your test fail at some point, you can't trust them. You don't know that they actually verify anything. Third step is to write the simplest code that's going to be making the test pass. So here, the most important thing is the simplest code. Is you don't need to be clever, you don't need to be to try to optimize things. You just need to, okay, I need to make the test pass. That helps to write something that's relevant and not overcomplicate things again. And of course, then you verify that the test succeeds. Pretty self-explaining. And then you have the last step that some people forget, that is refactor, enhance, comment. Basically, you know that your code works, you know that your tests are reliable because they are testing something. Now you can actually improve the quality of your code. So you can actually refactor some things, you can introduce some design pattern that you discover would help what the actual implementation does, and you can improve things. And once you've done that, repeat. So you don't stop once the first test is green. You can always add more test cases. You can always improve the code and make things clearer. And one thing that's important here, the refactor enhance comment, it doesn't only apply to your code, your source code. It also applies to your test code. So you can improve both things at the same time. So now we're going to see some ways that the test can go wrong. And this is very important to have in mind because writing tests is code, and so it can go wrong. One of the things that I had in the past is that all my tests involve users named Bob, age 42, working at the same Fubar Inc. Okay, and I mean, this is sample, but you use test data and you say, okay, my test data is going to be 1, it's going to be 7, it's going to be my lucky number, and you're going to use it everywhere in your tests. Problem is, when all your fake data is foo and 42, how can you be sure that your test is valid? I had this issue in some tests of mine where I'm testing something and I say, okay, I need the result to be 42 because that was the user ID I added as a test data. Problem is, there was some error in my code, and the value that was returned was not the user ID, it was the company ID. But the company ID was also 42 because I used 42 everywhere. And so the result was correct, the test was green, but the problem is that the 42 I got didn't come from the correct place. So how can we mitigate this? Well, you can use fuzzy data in your test. Basically, you generate random data that's going to be included in your test. And that way you can first define the boundaries of what's valid and invalid input, because you have to think of, okay, how do I generate random data that looks real and that's valid? But also it can help you find the edge case, because one of the problems with this is that in addition to not being sure where the value comes from, you only test your code against one single value. So you're testing your code and your code works with 42. But what if it's 43? What if it's 2,000? What if it's 1 million? You don't know. You just know that it works for 42, and that's all. So you can find the edge cases because every time you run your test, it's going to be a different value, and it's going to be a different combination of value that's going to make sure that sometimes you're going to find some edge cases and say, okay, actually, if the user ID is greater than this and the email address is something like that, we have some issue. I have created a Kotlin library that's called Elmer that actually helps to do this. So you can include it very, very easily inside a JUnit test. And basically, you have a lot of helpful methods to generate numbers, strings, arrays, and lots of other things. So here are just a couple of examples. Like you can say, okay, I want my ID to be an hexadecimal string because all my IDs are hex strings. I want an email address, and this email implementation can generate email that follows the RFC, and most of the time they don't look at all like your first name dot last name at company.io. It's actually a lot of weird email address that you're going to get. You can even add some regex. So you say, okay, I want a string that matches this regex, and it's going to construct something that will match it. And sometimes, if your test fails, this is going to say, okay, actually the test failed for this seed value, and you can actually reproduce it. Because one of the main points of unit test is to be reproducible. So when you use random data, you need to be able to say, okay, I failed with a random data, but I don't know which one. Here it tells you, it's going to say in the error message, I failed with this error with this seed value, and you can reproduce it by using putting this code at the beginning of your tests. So it's in GitHub, open source, so you can of course go and grab it and send pull requests and issues and comments and whatever. I'm going to have the link at the end of the presentation too. Then there are mocks. I didn't cover mocks yet. Basically, mocks are fake implementation of classes or interfaces that you have that can be driven to mock, to mimic the behavior of a class. Like for instance, you need to use a queue inside the feature you're testing. You don't want to have a concrete implementation of a queue because it can be a linked queue, it can be a buffered queue or whatever. So you want something that's just an interface, and that's just going to be driven to be used inside your test. The problem is that how can you be sure that the mocks are consistent across your tests? Because basically, it's the test class that says this is how the mocks is going to be behaving, but it doesn't say that it's coherent with the rest of your code. So for that, there is this queue contract pattern that I use, this mock contract pattern that I use, where basically you have a single class that say, okay, this is how I am going to mock a queue, for instance. And that, for instance, when I say prepare empty, well, it's the isEmpty method is always going to return true, and get first is always going to get an exception. So, code coverage. I mentioned it earlier. Code coverage usually is saying how much of your code is tested. Well, that's wrong. 100% coverage doesn't guarantee you anything. For instance, here we have 100% coverage. But did the test pass? Not really. So the problem is that code coverage works by looking which methods in your code are called during the test. So we just actually say, yeah, we visited 100% of your code, but we didn't test anything. So TDD fail first paradigm ensures that actually you do test something, because you know that the test can fail. And it means that in every single test you have, you need to have that last part, which is the verifier, the assert, or the make sure that something, that you verify something inside your code. Just one thing to know is that you shouldn't think of code coverage as yeah, I have 20% of my code tested. You should think that at least 80% of your code is not tested. Look at the other way around. And never, never, ever give the code coverage information to anyone outside of the tech team. Because when it goes to management and whatever, they're going to say, oh, we have like 20%, we should go to 50%, we should go to 100%. And they think it means something. So a bit of a practical process, how you include this in your daily workflow. You can create tests very easily in Android Studio. You just have this action that's called create test, and it's going to have like all the methods that you need to start. You can, here's the very basic example. Say, okay, I have a user named Bob, of course, and I'm just going to compute his age and make sure that it works. You have the 3 steps: prepare, act, and assert. Then you have other test cases. So we have the, this is my naming convention. You don't have to use it, but I have what feature I'm testing, which is here compute age, and the case I'm testing, which is case OK. Then your impossible case, like I'm testing a user that's born in the future, right? And it's like, yeah, we shouldn't be able, and it should raise an exception. From within Android Studio, you can run your tests directly, which is very helpful, and you can debug them from Android Studio. You can also have some Gradle tasks to run them for you from the command line. And actually, you can launch them locally regularly. So if you do TDD, you launch them all the time. If you don't do TDD, you still need to launch a test regularly while you develop your features. And you can also run them all on a CI server. So if you don't already have a CI server, you have lots of available servers that can be set up in like just 5 minutes, like Travis, Bitrise, Circle CI. There's Jenkins too, but Jenkins needs more configuration to work, but they all work very fine and can listen to every single commit you push or every single PR you push to run the test for you. For Android, you have a few frameworks that you can that are already included. Like by default, you have Java JUnit. You have the spec and Kotlin test frameworks when you're working with Kotlin, and they are quite nice to use. You have several mocking frameworks, so Mockito, EasyMock, Mock, which is a Kotlin mock framework, and the 2 case. And of course, you have my Almir library for fuzzy testing. And for functional testing, which is basically testing that you launch your app in a UI and simulate user interactions and make sure that you go to the right screen and the correct things happen, you have Espresso, both Robotium and Appium. So one last thing is a few rules of thumb, because sometimes, okay, how much test should I write? A large fraction of the flows in software development are due to programmers not fully understanding all the possible states the code may execute in. These are rules of thumb that I use to know how much tests I should think about. Like you have a for loop, okay? What if the count is 0? What if the count is less than 0? What if it's just 1? What if it's a small number like 10? What if it's a very large number? So you need to think about all of that. You don't necessarily need to write tests for all of that, but you need to consider it when you write your test to say, okay, are there special cases that can need a dedicated test? If you have a for loop over a list, likewise, you have all those cases that you need to include about the size, but also what if the list is sorted or unsorted? What if there are duplicate values or duplicate references in your list? You need to think about all that. Most of the time, you don't have to. You just have to write like just a couple of cases. But sometimes you actually need to have all these implemented. When you have an if statement, well, an if statement, unless it's just one if, one Boolean chain, you're going to have some multiple conditions that combine together. And the more conditions you combine, the more cases you're going to have. Like, what if here we have just 2 values and there are already 4 cases, and you add 1 value, it's going to be 8, and so on and so on. So you need to consider all of these. Likewise, when you have if and else if, or when you have switch when, you need to consider all of those. Also, when you have function parameters, if you have an int, what if it's less than 0? What if it's infinity? When you have a string, what if it's a null or empty string? Or what if it uses weird characters? If you have a float, what if it's less than 0, another number, or a very small amount? You need to think about all that. So just a quick conclusion. When you're going to test, you're going to have to have the proper mindset. First of all, you need not to think of bugs as failure. Bugs are insights that you can improve your tests. And whenever you find a bug, be it when you are coding, on when you are testing, on when you have a beta, when you find a bug, you always write a test that covers it. Because if the bug happens once and you fix it, maybe someday someone is gonna, delete that lines that, fix the bug because it doesn't understand it, and the bug is gonna reappear. So you use a test that say, okay, I'm gonna cover this bug specifically. You should grow your code and test hand in hand, and one step at a time. So make sure that every time you improve your code, you also improve your tests. You always need to try to think about what can go wrong. And it's thinking about all the edge cases, all the mixed states, the combinations that can happen. And finally, you need to know that test is code, because you write it in Kotlin or in Java or in any other language. And if you have bugs in your production code, you can have bugs in your test code too. So you need to be aware of that. And also, because it is code, you can use all the patterns, all the cleverness that you have inside your test. So you can have inheritance, patterns, anything that you can want to. One other thing, you need to be as confident in the test that you code as you are in the code that you test. You need this confidence on your application code and on your test code growing at the same time. If you want to go further, you can look at your platform's best practices. You have lots of links all around the web, blog posts, tutorials, videos that cover how to test in Kotlin, in Android, in whatever. And you can also explore patterns once you're familiar with testing, like mutation or fault injection testing or property-based testing, and so on. So we can discuss that afterwards, of course, but you can always go further with tests. So that was me. Thank you very much for your attention. And if you have any question, I'm very glad to answer.
Xavier, thank you very much for this manifest. I think this is excellent motivation. And while you're preparing your questions, we have some present for you. Thank you.
Thank you very much.
Questions, please.
Hi, thank you for your awesome speech. And you said that you have unit tests, component tests, and UI tests. And how many tests?
The short answer is not enough. I didn't look at the number right now because you have a quite short code base. I think we have like 5,000 tests, something like that. We don't have a lot of UI tests, but we are trying to improve them as we speak. And I'm actually in the process of writing a new convention and guidelines and tutorials internally to how to write tests and find new patterns to write tests more easily.
And UI test, it's end-to-end test or just a screen test?
It depends. We have some smoke tests, but the problem with end-to-end test is that it needs a lot of time to analyze. Because when you have an end-to-end test, you are working with a real database on disk, you are working with real network, real APIs, and the problem is that when you have that, you can have faults introduced by something that's not inside your application already. So in the previous company when we had that, you had these end-to-end tests that covered lots of scenarios that would run every night. And every morning you had someone that had to go through each one of them and say, okay, this was introduced because of a network error, or because of an API error, or this was actually a bug inside the application. So basically, end-to-end test is it's powerful because I mean you cover the user experience, but you need to have someone try to reproduce every error and say, okay, it's actually a bug or it's just a fluke in the somewhere within the end-to-end chain.
Okay, thank you.
You're welcome. Yeah.
Hey, thank you for your presentation. The question is, let's imagine this situation. I have 3 methods, 1 public and 2 privates.
Yeah.
Method A is public. It calls method B, which is private, and method B calls method C, which is also private. And all these 3 methods are quite large. I need to test method A. What should I do? Which will be the best strategy for testing this method?
So basically, when you talk about testing, you have this concept of black box testing and white box testing. Black box testing is thinking of the feature you're testing as just an interface, and you don't know how it's implemented, and you just say, okay, I want this to work. Like, for instance, if you're testing sorting an array, okay, you have lots of implementation, lots of ways to sort an array, and you just want to say, okay, when I call the sort method of this array, I want to verify that every each item in it is in order. And black box testing is just saying, okay, I'm creating an array in any order, I call sort, and then you just verify that the result array is sorted. White box testing or clear box testing is knowing how the feature is implemented internally. And so basically, if you do that, you are gonna actually make those methods not private but protected or internal in Kotlin. And you're gonna say, okay, I'm actually gonna test method C and verify that it changes the state of the feature or the object correctly. I'm going to test feature B, the method B only, and then you're going to test method A. And basically, you're going to cover a lot more cases for method C, and maybe a little less for method B, and a little less for method A. But in general, I usually favor black box testing, because that way you don't restrict evolution in your code. Because maybe sometimes someone is going to say, oh, actually we don't need method C, but we do a method D, and we rewrite the method B, and so the internals change. If you do white box testing, you're going to have to also rewrite all your tests. But yeah, basically the idea, even if the method is large, it doesn't mean that you have a lot of tests to write, because it's all a matter of how many cases you have as inputs and outputs, basically. Or how many callbacks are going to be called, how many stuff like that.
Hi, thank you for your talk. I have questions. What do you think about the naming of the test methods? Should we use test function, state, and return value, or something other patterns? When we have a lot of tests, we need to understand what these tests do.
Yeah, so that's a very good question, and I can't give you a definitive answer. Because it's very subjective. In my opinion, first of all, historically a lot of test methods when I test foo or test something, which was basically because JUnit used to work by reflection, and it says, okay, I'm going to execute all methods that start with test. Nowadays, you have annotations, and you have all the other ways of writing tests. You shouldn't name a method test, because it's in a test class, so you already know you're testing something. You shouldn't name it should, because you don't want to say that this feature should work, because should means that you accept failure. So usually what I do is what I showed earlier in my methods nowadays. I'm writing like the name of the feature I'm testing. So it could be the name of the class, the name of a method in the class, or the name of just something that's exactly what I'm testing, and then I'm going to have something after that with an underscore that says what case I'm going to say. Here I'm just saying OK just for brevity, but you could actually say OK, I'm testing with a valid user. You could indeed in the method describe the inputs and outputs, describe the edge case and the expected result. It's all a matter of what feels good for you and what feels the most readable for you. So it's very subjective, and you have to test. But I found this is very, very nice because basically it reads as quite easily. And what's nice with Kotlin is you can actually have method names with spaces if you use backticks around it. So you can actually write your test name as a natural language sentence.
Thank you.
Hi, do you hear me?
Yep.
Hi, thank you for your talk. And I have actually two questions. The first one is, if you have to test something, what does cover single unit test case? Maybe, for example, you test some network manager which sends requests, sends receive response, make some caches, and callback, callback. So, do you have to test in different unit tests the making correct requests, the making callback after the request received, and making cache value?
It depends a lot on what your manager does, but basically the idea is you could want to cover different success scenarios. Basically, each unit test should cover a specific scenario, and in theory, you could know how many scenarios you want based on how many ifs and fors and switch and whatever you have inside, how many branches you have inside your code. But let's say, just take for your example, you want to test the valid case. You have you want a request and you have an answer, so you don't have any network error, you don't have any timeout, you don't have any server error or whatever, you don't have any parsing error. Basically, you still need to test a couple of things. What if you have like if your manager does more than just calling the server and transferring the response, if there is some kind of processing, for instance. To give you a concrete example, we have something inside OKHTTP in our application that adds some headers in some cases. And basically, we're going to have to test some cases that success and that needs to have the header added, and some cases that success that don't need the header added. So it's all a matter of which scenario you have. But the thing is, your network manager in itself is a very complicated thing. And usually it's going to have dependencies. It's going to have a dependency that say, okay, I'm parsing the result from JSON to whatever model you have. I'm going to have an interceptor that's going to modify the request to add a header, or to remove a header, or to encrypt the content and stuff like that. And each part of it, so the parser is going to be tested on its own. The interceptor is going to be tested on its own. And when you write your test for the network manager, you're going to just say, okay, if you're going to mock the interceptors, you're going to mock the parser, and for the network manager, you're just going to say, okay, I want the network manager to call the low-level network layer, and when the result comes, I want it to go through the parsing, and I want the result of the parsing to return as in the callback. And that way you can just simplify your network manager by just testing that the network manager delegates what needs to be delegated and does what it needs to do, and each delegate can be tested on their own.
Okay, thank you. And small question: if you said we haven't to tell managers about code coverage, what we can tell them to make them happy?
The thing, yeah, I know what you mean. Basically, you can just, if they want a number, you can say, yeah, we have 2,000 tests, we have 3,000 tests, and you can always find some value and give it to them. And I think number of tests is a valid number to give, because it actually is saying, yeah, we have a lot of tests that are written. But then again, it's always the same thing. Just to tell you why we don't want to tell manager this, in a previous company I worked for, we had the CDO who wanted us to test thoroughly the applications, which is good, you know. And so there was this incentive that say, okay, right now you are 5% coverage. If you get to 15% coverage, you're going to have a raise at the end of the year. Okay, so it's good. In theory, it's a good incentive that say, okay, if we test more, we're going to have more money. Good. Problem is, because the code coverage doesn't mean anything, it was very, very easy to get to those 15%. We call the methods assert true. Yeah, never fails. So all the tests are green, but we didn't spend any time actually testing anything. So this is why, because when you give the information to a manager, if it's not just, you know, they're gonna assume that it really means that the application is 20% safe, which it's not. It's not what it says. And they're gonna want to drive the code coverage when sometimes you can't achieve 100% coverage. Like if you use data classes, right now the code coverage is gonna ignore anything that's generated by Kotlin. So the getters are not, getters and setters are not covered by your tests. The hash, the toString and anything like that is not covered by your test. And you shouldn't, because I mean, it's all generated. But because of that, you're never gonna get to 100% coverage.
And the last question, please.
Yeah, thank you. Thank you for your speech. I've got two questions. First, you talk about random values in the test. I just want to make it clear. Did you mean it should be used in addition to the main tests, or something else? Because they don't cover edge cases or.
So yeah. That's a good question. When you are, no, it's all the way around. Here, so yeah, basically when you test something, the random is used in the main test. So I don't have a main test and then a random test. I only have my test, and within those tests, I create random values. But the thing is, I create random values that are guided. So this is why I have this hexadecimal string. So here, this would make my test like successful test. It's a valid condition because the ID looks like an ID, the email looks like an email, and the phone number looks like a phone number. And then I would have another test that says, okay, my ID is going to be like an alpha string or an empty string or a null string. My phone number is going to be actually formatted with something that I can't parse. The email is going to be actually a URL and stuff like that. Or it's going to have the mail to in front of it or whatever. So basically, when you create your random data, you're going to want to drive them to fit inside. This is a valid case, and this is an edge case. And you can do that very easily. Like, for instance, okay, I'm going to say I want a number to, I want to generate a list of valid strings, and and then I'm going to have another test that generates a list of invalid strings. And they are both going to be driven to be either valid or not valid.
Okay, thank you. And the last one, I have asked it already yesterday to another speaker. And I just want to hear your opinion. How can we calculate the cost of the feature, including unit testing?
It's well, it's kind of the same thing as calculating the cost of a feature, because a feature's cost is going to be dependent of the amount of code you're going to have to write, but also the complexity about external dependencies that you don't control and that can go wrong during development. Calculating the cost is if you've never written any unit test at first, you can just like double your feature development cost. And like everything in Agile, you can start with an estimation, and as you go, sprint after sprint, you can adjust this estimation to be more accurate. So if that helps, you can, when you have your Jira ticket or Trello ticket or whatever, that says you need to write this feature, you can create a linked ticket that says I'm going to test this feature. And basically you can have a different estimate to both and say, yeah, we're gonna have this fine-grained values that we can measure, and we can fine-tune them later and know that, oh, actually testing is taking less time or it's taking more time.
Yeah, thank you. Very interesting. Thank you.
Okay, and the last part, I know it's hard, but you need to choose the best question.
Yeah, best question. I think your question about testing the manager with private methods was very interesting, so I think best question.
Okay. Thank you.
Thank you.